Okay, so I'm doing part B of 50 on page 128. Scientists hope to reduce the frequency of undersized tomatoes to no more than 4%. I think maybe I ought to get another model over here. So we know that an undersized tomato is 70 grams, right? That's what people don't want, right? And we know that right now the mean is 74. But what the question is saying, they want the 70 grams to be no more than 4%. Everybody see how I drew that? That's what they want. They want the 70 grams to be no more than 4%. And the standard deviation is still going to be, what was it, 3.25? Is that what it was, 3.25? I'm going to say yes. I hope it was. It was? Okay, you know what? Let's pause this for just a second and make sure. Okay, so I need to find a new mean that is going to make 70 grams only 4%. Only the fourth percentile. I need a new mean to do that. Well, how are we going to do that? I say let's throw some spaghetti against the wall. So I have z equals y minus y bar over s. I have my y is 70. I don't know what my y bar is. That's what I'm looking for. I know that my s is 3.25. Let's erase s and put 3.25. What's my z? How am I going to find my z? Kristen, what am I going to do?
You do the
Go ahead.
the inverse, and then you 0.04.
I think that's correct. Inverse norm of 0.04, which is my 4%. I'll press enter. My z-score for that is negative 1.75. So I can just fill that in right over here, negative 1.75. And now I have a nice equation that I can use to solve for y bar. Everybody with me? Right, so if we just do that, I'm going to get 3.25 times negative 1.75. I'm just multiplying this over to here to get rid of the denominator. Is everybody comfortable with that? Okay. Is equal to 70 minus y bar. So I have 3.25 times negative 1.75. So that gives me negative 5.6875 is equal to 70 minus y bar. I think I'll subtract 70 from both sides. So I get negative 75.6875 is equal to negative y bar. So my new mean that I need to set this machine to, or these tomatoes to, or whatever, I have to strive to develop a new strain, is going to have to be 75.6875 grams. I'll just round that off to 75.69, 75.7. Does that make sense? Let's see if that's right. It is. That's correct.
What number is that?
Okay. So the researchers produce a new variety with a mean of 75 grams. That's okay. Which meets the new 4% goal. Is that right? 75 grams? Is that what we said? Pretty close? Pretty close. Close enough. They make one with 75 grams, and that meets the 4% goal. Oh, no, I take it back. All right. So we needed a tomato with a mean of 75.69. Let's call it 75.7. But they're saying they made one, but it's only 75. Not quite big enough. But it still satisfied the goal of only 4% ones that are no good. So what they did was they made a little bit smaller tomato, but they also changed the standard deviation so that we still have that 4% rejection rate. Am I making sense here? So I'm gonna draw it. I'll try to draw it. Okay. I have a new situation here. I have an N. They said they made a 75-gram tomato. And that, so this is 75. And then somewhere over here is 70. And in fact, this is only 4%. Now we thought before when our standard deviation was 3.25, so we could have had an N 70. We could have had an N 75.7, comma 3.25, but they managed to enable to make a little bit smaller tomato and still meet the 4% goal. So how did they do that? They did that by changing the standard deviation of the tomatoes. They made them more consistent. Are you with me here? So like just to go to an extreme here, if I had if my mean tomato was 75, that was the average size tomato, and my standard deviation was 0, how many tomatoes would pass the 70%, the 70-gram test? Here's my normal model. I have my mean. My standard deviation is 0. That means every single tomato is exactly 75 grams, right? There is no deviation. I didn't even have any deviation. It's all right there at 75 grams. Are you with me here? So there are no tomatoes that are less than 70. All the tomatoes would be accepted in that case. So by compressing the standard deviation, by making them more close to what the mean is, I have less to worry about. There's fewer tomatoes that are going to be less than what people will accept. All right. So let's figure out the number here. Z equals y minus y bar over s. What data do I have? My y is 70, right? Yes, that's what it's too small. My y bar is 70. My y bar is 75. I don't know what my s is, but my z is still 4%. What was the z score for 4%? Negative 1.75 equals negative 1.75. What's my new standard deviation? Well, I'll multiply both sides of the equation by s. So I get negative 1.75 s is equal to negative 5. I did this subtraction up here. Did I go too many steps there? Is that okay? Yes?
It's okay to round it from 75 to 75. You know how our mean was 75.7?
Okay, our mean before was 75.7. But what they're telling me in the problem was that they actually managed to create a tomato that's not even that big. They didn't have to go all the way up that high. They managed to create a new tomato that's only 75, but since they were able to create it with more consistency, the standard deviation is less, and that's what we're trying to find, the new standard deviation. Okay? So, so I divide both sides by negative 1.75. And I get my new standard deviation is equal to 5 divided by, well, by 1.75. My new standard deviation is 2.86. So my new model here is an N75, comma, 2.86.